Okay, so today to get started, let's start by talking about our results from our transfer techniques. So here we have growth on our slants. You can see this by looking at the auger, and then when we rotate, you can see growth bacteria on your slant. And remember when we did this, we simply took a loop and dragged across the auger. And then here is a much better looking example of our serratia that we plated last week. And again, we have a little bit of growth at the bottom of the auger, but again, we have that streak forming on our slant. And then now, we can look at 3 different liquid broths how we did. So we have serratia, BMEG, and then Micrococcus luteus. So one thing is you may have noticed, serratia, when it has its growth, always has a reddish color. And as you can see, this is what we might refer to as turbid. So this is when we have a lot of growth in broth. So it has a kind of not clear color and kind of milky color. So now looking at our pour plates and our streak plates. So as mentioned in last video, one thing that you may have to do is dilute your bacteria, and then if you were to mix bacteria and streak for isolation, to separate your 2 bacteria, you definitely would want to dilute these. As we can tell here, both my serratia and my micrococcus plates have a full lawn of growth. So I'm going to open these up in my flame, and you can kind of see that all of the auger is covered by bacterial growth. And it's a lot more obvious in micrococcus. So you can see a full lawn of growth, micrococcus. And now, let's look at our streaked isolation. So, here are some good examples of streaked isolation. So, we see a full lawn, the left part of the plate, and then as we streak, we see that we go from a lawn to close, clumped up colonies to finally isolated colonies. Now, this plate's grown for almost a week, so if we would have taken it out after about 2-3 days, there probably would be a lot more streaked isolated colonies in the streaked isolation. And as I discussed with you last time, is if I do streaking to isolation right, I could streak to isolation 2 different bacteria on the same plate, which is shown here. So on one side is serratia, one is E. coli, and as you can see, both have isolated colonies. And again, this is another case where I would want to have this grow over a few days, not like a week that we've had it grow. So this grew over the weekend since last Wednesday. Alright, so today what we're going to be doing is covering dilutions. So I've already taken the time to label my dilutions. So we have our original bacteria here, have 10 to the minus 2, so we'll get into this in just a moment, but the reason, here I have my 10 to the minus 2 dilution. So the reason why this is 10 to the minus 2 is because I'm taking 1 milliliter of my original sample, and I'm placing that into 99 milliliters of dilution. So then I'm diluting it 1 to 100, or 10 to the minus 2. And then from my 10 to the minus 2 dilution, I will take 1 milliliter and place it into 9 milliliters for a total volume of 10. So this will be then 1 tenth of 10 to the minus 2 or 10 to the minus 3. And I'm going to repeat this from 10 to the minus 3, take 1 mil into 9 mils for 10 to the minus 4, and so on to 10 to the minus 5 until I have 10 to the minus 6. So how I'll do that is I have my sterile pipettes in this container, and then I also have an electric pipetter that will be used to draw up my solution. So it's very important that when taking from any of these previous dilutions, you should change tips. So, or if you're going from one bacteria to another. So the reason I would change tips from 10 to the minus 2 when I plate that, so I take 1 mil from our original solution, put it into 10 minus 2. If I keep using the same tip, I'll still have residue of my original dilution in the tip. So that will actually throw off the dilution. So that's why it's important to change tips between each dilution here.
Okay.
So to get started, what I'm going to do is I'm going to open up my container here, and I'm going to just briefly flame and take 1 tip out. Okay, it's important actually not to touch your tip to any other surface. So put this in here, and I want to make sure that I shake up my bacteria. Again, as always, working in a sterile environment. Flame, and then I'm going to take 1 mil. I'm going to press on the top trigger here to pull up. So you can see I did a little bit more, or this tip is a mil. So I'm going to take up 1 mil, my pipette. So all the way up to the 0 on one side, or the other side. I'm going to flame my bacteria. Now, I'm going to take the bacteria, put it into my 1/100 dilution, and then I'm going to take a moment to change out my tips. Okay, so now that I've taken my original solution, my original growth, I'm going to put this back onto my incubator shaker so you can then look at the growth curve after about an hour, hour and a half. So now what we're going to do, since we've transferred and diluted our bacteria, is we're going to then plate. So how we plate is we only take 100 microliters or 0.1 mils of our dilution from the tube onto the plate. So because we're taking 1 fraction, a tenth of a mil, this plate, 10 to the minus 6, when I take 0.1 mils will actually be a 10 to the 7 dilution on the plate. If I were to take 1 mil from 10 to the minus 6 and plate onto my auger here, my TSA plate, if I were to take 1 mil of my 10 to the 6 dilution onto my TSA plate, then it would be 10 to the minus 6. So always keep this in mind when you're doing your dilutions. Everything is always in a fraction to 1 mil. So 1 mil to 1 mil is the same. However, if I take 1/10 of a mil, that means I need to account for that dilution. So I'm going to briefly label all my plates here. So I have my 10 to the minus 3 from 10 to the minus 2, 10 to the minus 4 for my 10 to the minus 3, 10 to the minus 5 for my 10 to the minus 4, 10 to the minus 6 from 10 to the minus 5, and then 10 to the minus 7 from my 10 to the minus 6. So, one thing that we do now to actually save the amount of tips that we use is we can actually reuse my tip that I collect 0.1 mils of 10 to the minus 6 to plate and then reuse it. So unlike when we were taking the dilutions from a higher dilution, now since we're working up to higher dilutions, this dilution here will have a negligible effect when reusing into this dilution. Now, if you were to be using different bacteria, you definitely need to make sure to change out your tips. So now I'm going to take 0.1 mils. So that would be up to where the 9 is. So this is 1/10 of a mil, or 100 microliters, where this 0.9 is. So one thing I do is I also take up some volume and put it back into the tube to mix up my liquid. So it's 0.9 on the tip, which is 100 microliters, working inside my flame. I'm just going to plate. As you can see, it's not a whole lot, and then in a moment I'm going to spread this. to spread.
Yes, we do. It's in the back.
Okay, how fast do these cool down? I haven't used one of these before.
I usually just touch the agar, so I like let it cool.
Okay. So,
My silk card.
okay. So now what we're going to do is use a glass or metal spreader, depending on what you have in lab. There also are disposable spreaders as well. So depending on what you're using, you need to make sure to flame sterilize your spreader if you're using a glass or metal spreader as we're using. If you're using a disposable spreader, normally those will come in sterile packaging and you would use it and then toss it. So I'm going to lightly touch my spreader to the auger to make sure that it's cool. Okay. And now what I'm going to do is, can we see this reflection of the liquid?
Yeah,
You can?
a little bit.
Okay, so what we're going to do is we're going to take our liquid and we're going to spread it around, rotating until basically we don't see any more liquid. So we want to make sure that we spread into our TSA such that we don't have a bunch of runny liquid anymore. So this will make sure that I have a relatively even lawn. And again, make sure that you rotate your plate while you're spreading. So now we can see a difference between what we had before when we could see liquid, and now we can't see any liquid running on the plate. Let me see it. So now I'm going to close this. Now actually label this again too, because we're looking at growth, so I'm going to say pre-growth. So now that we've waited about an hour and 15 minutes, we're now going to take 1 ml back from our bacteria that we had growing, and we're going to re-dilute this into now fresh, sterile dilutions. So this is going to be a repeat of what we did earlier at our initial dilutions. So it's just a reminder, 1 ml into 99 mils for a total volume of 100 mils is taking 1 out of 100. So 1 ml out of a total 100 volumes is 1 over 100, which is the same as saying 10 to the minus 2. And as I take 1 mil from 10 to the minus 2 and add to 9 mils, it's 10 to the minus 3 because it's a dilution of 1 to 10. And so on and so forth, 10 to the minus 4, 10 to the minus 5, 10 to the minus 6. And then again, as a reminder of how our plates work, when I take 1 over 10 or a tenth of a mil and plate, that is going to be a 10 to the minus 3 dilution. And then so on and so forth for each of my tubes.
Yep.
So as a reminder, when you're taking up your bacteria, make sure to pipette up and down a few times to make a homogeneous mixture of your bacteria before you transfer. So this will make sure to resuspend any clumped growth. So now I'm going to take up 1 mil. Oh, that does looks a little bit more turbid. You can see, maybe not, but you could look at the difference of how much bacteria is in this second dilution after growth as compared to your first initial dilution. So when you do this in lab, you'll be able to see a slight difference, but it's not going to be obvious.